Okay, so today we're going to explore more how to use our z-scores. Okay, so we talked about yesterday, there are millions of different normal distributions, but how many standard normal distributions are there? One. Okay, so when we convert to a z-score, we are standardizing that data so we can use that standard normal distribution. So in our z-score formula, which is right here, what does x represent? The data. Whatever piece of data you're looking at. What does mu represent? The mean. And what does sigma represent? Standard deviation. All right. Now, when we're converting every value in a distribution to a z-score, that is called standardizing. Okay? A standardized distribution no longer has units because when we divide here, we're dividing out our inches or our feet. We're eliminating our units so that comparisons can be made between those distributions. Now, when we look at a standardized distribution, the mean, mu, is always what? What number?
No.
When we did our standard normal yesterday, what did we say the mean was every time? Zero. All right? And we have a standard deviation of what? 1. All right, so an observation's relative standing is not changed by standardizing distribution. You're going to see that in just a minute. We're going to do it on this graph. So you're going to see that the shape of the graph is not going to change. So that shape stays unchanged. We just change how we deal with it. All right, so we're going to tie back a little bit to the empirical rule, then we're going to leave the empirical rule. So we're going to leave our estimation. We're going to go towards a more exact way of operating. All right, so here we have yields of apple trees in an orchard. They have a normal distribution, a mean of 42.4. So if we were using the empirical rule, we would start there. And it says it has a standard deviation of 6.1. So we would finish by adding 6.1 to this side. And this would give us 48.5. It would give us 54.6. And then finally, 3 standard deviations from the mean would be 60.7. Then we would subtract that 6.1 to go backwards. And we would have 36.3. And then 30.2. And 3 standard deviations to the left would be 24.1. All right, so this says, what does the empirical rule say about the yields of the trees? Well, this is what we know. So this is 1 standard deviation, left and right. What percent of the data lies within 1 standard deviation of the mean from the empirical rule? 68%. So what does that tell us? 68% of the data lies between 36.3 pounds and 48.5 pounds. That should be pounds, not a percent sign, sorry. LBS. All right. Now, continuing to use the empirical rule. What's our next big number from the empirical rule? 95. So 95% of the data lies between 30.2 pounds and 54.6 pounds. So 95% of our crops should produce somewhere in between this. And then finally, 3 standard deviations from the mean. 99.7% would fall between 24.1 pounds and 60.7 pounds. So, if we had an apple tree that was only producing 12 pounds of apples, it probably has a problem, doesn't it? Because that's an outlier, isn't it? It's outside those 3 standard deviations of the mean. So it might be diseased. We might need to cut it down. All right. Now we're going to look at it differently, though. Now we're going to take and we're going to use the same information, but we're going to approach it with not the empirical rule, but we're going to standardize this data. And when we standardize the data, the mean is always 0, and the standard deviation is always 1, right? So let's go 1, 2, 3, -1, -2, -3. Same information, same graph, but now I'm looking at the z-scores instead of the actual pounds of production. Okay, so for part B, it says compute the z-scores for 36.3 pounds of apples. Remember, a z-score is the data minus the mean. All right, so the mean of apples, once again, was 42.4 pounds. And the standard deviation for the production is 6.1 pounds. All right, so data minus mean, divide by standard deviation. This gives me a z-score of -1. All right, so right here. Oh guys, look what's right there. What was already right there? 36.3. What did I get? 36.3. Do you see how the shape of the graph doesn't change? This still reflects the same data. All right. So, what does this z-score mean?
Standard deviation.
That a tree that yields 36.3 pounds of apples lies 1 standard deviation from the mean. That's probably still in a very acceptable range. All right, now, let's go the other way. Let's say we have a tree that has a z-score of this. A z-score of 1.95. That means we're close to 2 standard deviations above the mean, aren't we? Let's change the color. I'll make it green. So 1.95 would be really close to this, wouldn't it? So if we were estimating using the empirical rule, we would say the production is really close to 54 pounds, wouldn't we? Okay? But let's see what it is using our z-score. Remember z-score, data minus mean, divide by standard deviation equals the z-score. So this time we were given the z-score. Actually, let me move this a little higher so I have enough room for my work. We were given the z-score. All right? But what we don't know is the data. We do know the mean. It doesn't change. We do know the standard deviation. And we have to solve for x. So what's the first step in solving for x? Multiplying by 6.1. All right, and when we multiply by 6.1, we get 11.895 equals x minus 42.4. So then what do?
Plus 42.
Add the 42. And when we add the 42, we get x is 54 point, let's round it, 30. All right, so that's what we found this to be. So that's what x represents, 54.3 pounds of apples. Hey, was that pretty close to 54.6?
Yes.
Yes, it was very close. All right, now if we used the empirical rule to find what percent of trees yield fewer apples, we would need to add up everything up to here. wouldn't we? So would it be easier just to subtract that 2.5% that's over here? So using the empirical rule, we would say this is about, it says percent, 99.7%. No, that is not true. I said that was 2.5% over here, right? So if I took this 0.235 and this 0.0015, that is 2.5%. So that would be 97.5%. All right, now let's actually use our chart. All right, so what would we use this chart for? Anytime you want a area probability percent and you have a z-score, you would use the chart. Or anytime you have an area probability or percent and you want to find the z-score, we can go both ways with it. This time we have the z-score. What was the z-score? It was 1.95. Let's find it. Using our chart, our normal distribution table, we get point we get 0.9744, which would be 97.44%. So this is our estimation, 97.5. This is our more exact answer, 97.44. So empirical rule gives us an estimation. Using our standard normal distributions with our probabilities, this gives us a more exact answer. But they're pretty stinking close, aren't they? Yeah. All right, E. The orchard owner decides to make room for trees to grow and thrive and determines that trees in the lowest 2.5% of yield will be removed from the orchard. Okay, so we want the lowest 2.5%. So we need to find the area under the curve for the lowest 2.5%. That would be 0.025. We get rid of these guys. So this is our area under the curve. So this time we're going to start in the middle of the table and we're going to find the z. So if our area equals 0.025, then what is the z-score associated with that area? All right. Are we going to look at the positive side or the negative side? Negative side, because it's less than 50%, right? All right, so let's find the negative side. Oh, this is exact on here, isn't it? That's so nice. Did you get negative 1.96?
Yes, negative 1.96.
Did you get negative 1.96? All right, that's our z-score. All right, did I answer the question?
Yeah.
Yes.
I know I didn't. Because I can't go up to the farmer and go, Farmer, you need to get rid of all the trees that fall below a z-score of negative 1.96. What do I need to convert that to for the farmer? The number of pounds. How do I do that?
Divided by
Z equals X minus mean divide by standard deviation. I want to know the number of the pounds. Anything that produces less than this, I need to solve for X. I've got Z. I know the mean. And I know the standard deviation. Yes, you got to multiply.
And add 42.4.
Okay. So we're going to do 6.1 times a negative 1.96, and that gives us negative 11.956 equals x minus 42.4. So to solve, we would have to add 42.4 to that. And that gives us 30.444. So what would we tell the farmer? That they should remove all trees that produce less than 30.44 pounds of apples. Those are our underachievers. All right, backside is going to be your homework. Backside is for you.
Yeah.